Assalamualaikum and a very good day and big to everyone. Welcome back to my class Organometallic chemistry. After 4 weeks of being idle and in a constant dormancy, so I believe everyone needs to have some revision on what we have learned before the PKP or MCO. I hope you are doing great. I'm doing fine here. So we're going to start with a few. We have to relook at our content of the syllabus first. So the first thing first, I would like you to open your Padlet and see under the column of about the subject. You can see that I have attached few details on the subject. For example, on the lesson plan. I'm sorry that this is not the latest lesson plan as in accordance to the newest academic calendar, but I just want to show you that the syllabus of our subject is still there. There's nothing much has been changed, except now we are going to learn these at a slower pace. So if you still remember, we had 4 weeks of lectures before this, starting 24th of February until 23rd of March. Before around 78th of March or 16th of March. So our last class was on 16th of March, if I'm not mistaken. So we have covered up to the second chapter, bonding of organic ligands to metals. If I'm not mistaken, correct me if I'm wrong. We have come as far as 2.2, where we had learned the EAN rule for pi donor complexes. But for the students that couldn't recall, I understand that since we had 4 weeks of holidays, so some of you might have forgotten a few things. So we are going to make a little revision on these topics again. So from chapter 1 to chapter 2. So bear with me. Worry not, we are going to have around 22 weeks of lectures instead of 14 weeks, as I have said in the WhatsApp chat. So inshallah, we are going to manage to finish all the syllabus on time. So I want you to relook at this syllabus content, but please ignore first the date. I'm going to show you the letter, second calendar letter, slightly later. Okay, just bear with me. And then so all in all, we have around 6 to 7 chapters, and I would like to put some emphasis on the assessment. As we all know, we are not going to have final examination this semester, and everything is going to be 100% continuous assessment. So how are we going to assess you? Continuous, the coursework is going to be 100%. Okay, the continuous assessment is going to be 100%. So let me show you the latest one, like this one. This is the latest one. Sorry. Okay, this is the segregation of the marks. We can see that the coursework is going to be 100%. Yeah. So 60% will be coming from your test. You're going to have 3 tests. Each test will carry 20%. And for the assignment, we are going to have 2 assignments, and each assignment will give you 20%. So total, we're going to have 100%. Bear in mind that I'm going to reveal the marks of your test only. The marks of the assignment will not be revealed. So we are going to use the same textbook and reference book. You can refer to these books, or you can refer to some online references. If you have any, please, you can put the link or the video or the PDF or the textbook that you find on the internet on the Padlet letter. So yeah, speaking of Padlet, all the videos that that will be recorded will be uploaded on the Padlet and then I will share it with you in the WhatsApp group, and I will get it uploaded also on my YouTube channel. So it's still 0 subscriber. So I hope you can subscribe later, and follow my channel. So I think that should be done on the lesson plan. Sorry that I'm going to prepare a new one, perhaps the most comprehensive one, because I'm still getting used to this new calendar. Now, getting back to your Padlet, this is actually the academic calendar that is distributed to all of us. This is from BHEA, Bahagian Higher Academic. So you can see that we have passed all these dates. Yeah. So we have used 4 weeks of our lecture. It was wonderful weeks of lecture, Alhamdulillah. And now we stop for 4 weeks due to MCO or PKP, and you had your mid-sem break for 2 weeks. And then now we are here again for the lecture. We start today on Monday, and it's going to end on 24th of May 2020. This is going to be on for 6 weeks. Okay, and the latest date of PKP will be ended on 28 April. Academic calendar. So this is kuliah 2. Kuliah 2 means this is the one that you are doing now for 6 weeks. From 30th April until 24th May, and then you're going to have your Hari Raya. I don't know how it's going to be like this year, but whatever it is, please stay at home and follow all the instructions given by the government and the Ministry of Health. Okay, stay safe. It's going to be 10 days of Raya, and then we're going to have our kuliah back on 4th June until 1st July. It's going to be 4 weeks of lecture again. So we put some study weeks here, but depends. We might be having some revision or some exercises that we're going to be discussing together. That will be decided slightly later. Okay, so you have to give me all your assignments. So far you have 2 assignments to be done. All the assignments to be submitted to me on latest on 21st July 2020. And we're going to have a semester break again until October 2020. Hopefully in the next semester we're going to have a face-to-face class, inshallah. Since it's going to be your last and final semester, let's make it the most wonderful one. Okay, now as I said earlier, I believe some of you might have forgotten the lectures that we had earlier before PKP. So I would like you to refer to your lecture notes again on your Padlet. I hope you can access to your Padlet. It is always available for you to download the apps. Yeah, because if you're using the browser, it's going to be a little bit difficult. Now, for the organometallic chemistry, so just to give you some idea on how far we have done, how far we have learned so far. So we have learned all these things, remember, up to the exception to 18 rules or 16 electron species, odd electron species, metal-metal bonding to complete the electron to the 18 electron rule. And we have learned also the effect of substituents on the ligands and consequently on the complexes. You can see we have talked about Tolman cone angles, and we'll talk about carbonyl later, anion. So I would say that we have covered at least 25 to 35% of this, which is quite a lot. So since we have plenty of time, so I would like to revisit our chapter again, if you don't mind, to learn again this thing. Ready? Now, students, if you still remember, the definition of organometallic compound is one that consists of metal to carbon bond. So again, be very careful. You cannot say that any compound that has metal and carbon is an organometallic compound. No. Even though you have metal and carbon in one compound, but they are not bonded directly to one another, it is not organometallic compound. Of course, there is some debates on this, but as far as your syllabus is concerned, we are bound to this definition. So please be very careful. If you want to define organometallic compound, it must be the compound that have metal to carbon bond. Now, since sometimes you can see that metal can be bonded to some other atoms as well, other than carbon, like you can see you have oxygen, you have sulfur, nitrogen, phosphorus, and so forth. These is related to organometallic compounds, but cannot be classified as organometallic compounds. Okay, so these are some famous chemists, or rather organometallic chemists, that work on organometallic compounds. We have learned about Grignard, Ziegler, Fischer, and also Hoffman. Now that is on the introduction. I hope you are following so far. If you have any question, you can always ask me on the WhatsApp. Okay. Now on carbonyl complexes. So for a complex to be formed, you must have organic compounds complexed or react with metal salts. Only then you're going to produce your metal complex. So carbonyl in this case is a metal complex, carbonyl complexes. So we are going to use CO as your coordinated ligand. Okay, so since we have done this before, so I'm going to skip that definition part. So let us look at CO as an ideal pi acid ligand. So if you all know, we have three main definitions of acid and base. I hope you still remember. This is going to be one of the questions that I'm going to be asking you slightly later in Padlet and also in the WhatsApp chat, and you have to answer this correctly. Remember that we have three different types of acids and base. So one of the definition is, for the ligand to be a good ligand, he must be a pi acid. So pi acid ligand that accept electrons from the electrons rich metal into the empty MO or LUMO that is of a pi type. Meaning, to be a pi acid ligand, your ligand must be able to accept electrons from the metal. So metal is going to have extra electrons to be given away to the ligand. So only then the complex can be formed. So the stability of carbonyl complexes can be described in terms of the back bonding. As I said, this is a synergic bond, meaning when ligands with pi acid behavior, commonly known as pi acceptors, as I said, and they will accept electrons. And once they accept electrons, they are not going to stay metals giving to the ligand. So this is going to determine the stability of the carbonyl complexes. I hope you still remember what carbonyl is and how does it look like, what would be how does it look like on IR spectra, and how we're going to identify it on FTIR. And also I hope you do remember how to draw the Lewis structure of your compound. Now we have carbon monoxide molecule. So carbon monoxide molecule is the molecule that is used to form carbonyl compounds. So in one given carbon monoxide molecule, we have carbon and also oxygen. So carbon is coming from group 14 and oxygen is coming from group 16. So carbon is having 6 nuclear charge, and oxygen is having 8 nuclear charge. So negative. Let me rephrase this. Your negative charge of the inner shell electrons, the number of inner electrons for carbon and oxygen is identical. They are having the same number of inner shell electrons because they are located in the same shell. Period. So they are going to have the same number of shell, but different number of electrons, definitely, and different number of valence electrons. So effective nuclear charge will be 6 minus 2, 4. So 6 is the total number of electrons, the total number of protons as well, and 8 of it is the number of electron and proton for oxygen. So 6 minus 2, 4, 8 minus 2, 6. So from the effective nuclear charge itself, we can tell that they are having different energy level. Okay. Now let us look at this diagram. This is the diagram. This is the molecular orbital. This is how molecular orbital is constructed from carbon and also oxygen. I hope you still remember how to draw this molecular orbital because it is extremely important for you to know. And as I said, for oxygen we have 2, 4, 6 outermost electrons, and for carbon we have 2, 4 outermost electrons. So we don't put the inner shell electrons here, first because they are having this number of electrons, and second because inner shell electrons do not get involved with the formation of bond or the formation of molecular orbital. So you see 2s of carbon is located slightly higher than that of 2s of oxygen. So they are having different energy. So there is no overlapping of orbital here. But you're going to see that there are overlapping of orbitals starting from 2s from carbon and 2p from oxygen. And the rest of the orbitals follow. So you can see it's stated here that HOMO for CO is sigma antibonding molecular orbital. So HOMO means highest occupied molecular orbital. So highest occupied molecular orbital for carbon monoxide is here. What about the LUMO? What about the LUMO of the for carbon monoxide? For you to know, for you to answer, okay, please answer me on this. But bear with this, inshallah. If you are sincere enough, you're going to get the message or the knowledge of this syllabus transferred. Thank you. See you.